Yeah, so our tagline is you have a chat, now what? Right? So integrating a chat system into your oh sorry, yeah, sorry. Integrating a LLM chat-based system in your product is now super easy. Conversations with software become this new standard and what users expect with when they visit your website. But now that we are beyond this hype of like chat is everything, how can we make chat really valuable for our users? And in this presentation, we'll share some of our ideas, our journey, how we build the chat system into our product that delivers real value. So before we start, I want to sketch out a little bit of our operating environment. I think it helps you understand the problems we face. So we build a platform called HackerOne, and we connect hackers with companies. Hackers finding security vulnerabilities, and our customers are actively trying to find those security vulnerabilities. Traditionally, hackers were humans, but I hope next time, this year, we see a lot of talks where we see hackbots or LLM-based or AI-based agents finding security vulnerabilities. We see it more and more happening on our platform. For bigger companies, dealing with security findings is a very, very complex process. Let me visualize it a little bit. This is first at our product security incident response. So this is a very matured way of dealing with security findings. And at a certain scale, we cannot just push security vulnerabilities or security findings into developers' hands. It's just too complex, and that's too much and too complex. So most enterprises have elaborate processes that acknowledge, fix, and deploy security vulnerabilities. So you might think, why are LLMs so interesting for us, right? This on itself is already complex. It depends customer by customer. But to make matters even more complicated, our inputs, so security findings, whether it's from bug bounty programs or pen tests, tend to be free-form documents. Although we encourage hackers or systems to deliver structured inputs, this very structure itself could becomes a bottleneck to describe the more complicated security vulnerabilities. So here is where LLMs help us out. They can navigate these free-form inputs pretty well and help with a lot of processes within this response system. So this is our HackerOne LLM chat implementation. We call it Hi. So in the presentation, we'll say Hi quite a lot, but that's the brand name of our chat integration. So as you can see, two screenshots. One where we have a new feature where you can ask our chatbot for gathering insights on your program, your platform, or your of your repos. And on the right-hand side, in this talk, we're going to highlight this functionality the most. It is our security findings overview, where the sidebar is actively trying to help you with any operation on the platform. So the introduction of chat was the easy bit, right? Like nowadays, it's a bit of JavaScript and you have your chat running. But making it valuable turned out to be quite a lot harder. We identified two key problems with developing a chat on our platform. The first one is observability. Like, we as developers do not know how our customers or our users interact with chat, and we don't quite understand where they get value. And the second problem we identified is discoverability. So we have the chat, but users cannot use it, or like they lack the insights of how to use this chat effectively. So let's zoom into the first problem, observability.
Yeah, so when we talk about observability in the context of conversational AI, we're trying to understand two key points. What are users discussing with our AI, and how useful are those conversations that they're having? And this brings us to a challenge. Existing tooling has proven to be insufficient in measuring the effectiveness of conversational AI, because it's heavily optimized for measuring distinct operations, like form submissions, page visits, and clicks. But chat is not a distinct operation. It's an ongoing flow spanning multiple exchanges. And the volume of chat is so much that we can't analyze it easily in a manual fashion. So this is why observability is so important. we need a systematic way to evaluate these conversations at scale to uncover patterns and to identify areas of improvement. So now let's discuss how we try to aim to answer some of these questions. So once we start analyzing conversations, as we said, the first thing we want to know is the topics of conversation. What is it that our users are discussing with our AI? And to do that, we use a technique called topic extraction, which helps us identify key themes and trends within those conversations. By analyzing the content of those conversations, we can identify common user needs, emerging patterns, and unmet expectations. So to do that, we periodically retrieve concluded conversations. And in our case, we consider a conversation to have concluded when the last user message was sent more than 3 days ago. We then execute a prompt which extracts relevant topic information from the complete message chain, of which you can see an excerpt on the left. The result we store in our database for further analysis and grouping. So there's a couple of things we want to highlight that we thought were interesting from our experience in prompting for topics. One is that we instruct the LLM in the prompt to generalize topics as much as possible, as this will help in further analysis and grouping. We also ask it to strip identifiers such as usernames and IDs, which again will make it easier to group topics. And last but not least, we provided an error path, which from our experience has proven to be very helpful in reducing inaccuracies and hallucinations. So when the LLM can't easily identify a relevant topic, we give it a way out. We tell it to return an empty array. In this case, we prevent the LLM trying to force itself to come up with the topic. So after grouping these topics, we're now able to determine what topics of conversation occur most on our platform. And as you can see, severity assessment and summarization are the most frequently discussed topics. But now that we understand what users are discussing, the next logical question is, how useful are the interactions that users have with our chatbot? So in order to determine how useful these conversations are, we use a similar approach to topic extraction, but instead of topics, we prompt for usefulness. So here too, we need a systematic way to analyze the conversation from start to finish. And this conversation level analysis should provide us a holistic view of how good the AI was in the interaction. So our evaluation consists of 2 parts. A quantitative score from 0 to 100, denoting the usefulness of the interaction, and then a qualitative reasoning, which gives us insight in the reasoning that the LLM used to come up to this score. This combination of quantitative score and qualitative reasoning gives us a much deeper understanding of how our AI performed, because not only do we know how confident it is in its usefulness, we also know how it evaluated itself. So this conversation level analysis gives a holistic view of how useful the entire interaction was, but it doesn't capture the nuance of individual responses within the conversation. And this is where message level usefulness comes into play. By evaluating each response, we're able to establish how the quality of the interaction evolves over time within a single interaction. So in a way, this message level usefulness complements the conversation level usefulness. It helps us pinpoint and identify at which point in a conversation AI does either excel or does not meet the expectations of our users. And this is actually quite hard because with chat you don't want to have too much latency, right? So you don't have the luxury of executing a lot of prompts to come to this conclusion and this evaluation. So we have to do this as part of the response. And this is how we do it. We embed the evaluation of the response inside of the response. An example of that you can see in the raw output, where the structured insights are embedded alongside the rest of the message. But this brings with it a new set of challenges, because the evaluation is embedded inside of the response. There's a risk where hallucinations in other parts of the response might poison and impact the evaluation of the actual response. And this is more present than with the conversation level usefulness, because there the evaluation is done in a separate prompt, so there's less risk of the hallucinations crossing. But how do we extract and process this structured information from the response? To do that, we use a technique called tag extraction, and we'll cover a bit more about that now. So let's take a closer look at tag extraction and why it is so essential, especially in a streaming environment. So in the screenshot, you see various tags that make up the raw response that we have to process separately. And as we all know, streaming always brings with it new sets of challenges. Because the chat is directly streamed to the client, the response, including those tags, have to be processed in real time. And adding additional payloads to the assistant message turned out to be a bit more complicated. So how did we solve this? Well, we created a stream buffer that captures the deltas of the LLM response stream. And then each delta is passed to a dynamic content buffer that aggregates these deltas. The dynamic content buffer maintains an internal stage machine that determines what content we are processing and invokes the appropriate handler. In the case of plain text, we pass the text to a text handler and it's sent directly to the client. When we detect an opening tag, we start buffering the content till we find a matching closing tag. If we don't find a matching closing tag, then the buffer is flushed and it is sent to the client. In the case that we do find a matching closing tag, then this tag content is processed separately. It's worth noting that this tag extraction goes beyond observability. Other metadata like contextual aware follow-ups or transparency around the AI's thought and reasoning process are also two use cases that we'll touch upon a bit later in this presentation. So now that we have established both conversation level usefulness and message level usefulness, let's see what insights we can derive from it. So here you see two graphs where we plot the conversation and message level usefulness over time. And this will allow us to identify trends. And as you can see, around the 3rd of November, we observe a dip in usefulness. And after investigation, it turned out that it's correlated to a change to our system prompt. So by reverting those prompt changes, we now see the message level usefulness go up again. It's worth noting that this goes beyond detecting changes in the system prompt. Like, new models are released on a very fast cadence, and from our experience, new is not always better. So it also is a great way to measure how different models perform in different use cases. So, of course, usefulness is only valuable if we can translate it to concrete outcomes, which is why we need to benchmark it against distinct metrics. We have questions like, do the insights of the usefulness correlate with actual user satisfaction and engagement? Do users find our AI helpful, and are they completing their desired tasks more efficiently? So one way we benchmark is by collecting direct user feedback. So users can, after a response, give a thumbs up or thumbs down rating to denote if they like the response or don't like the response. And now that we have the message level usefulness, we can combine the two and answer questions like, do the areas where the AI perceives high usefulness also correlate with high user satisfaction? And as you can see, we do indeed observe a higher usefulness score in cases where users give a thumbs up. We also track call to actions and conversation behavior. An example of that can be seen in this screenshot, where high is suggesting to report title suggestions to the user. We track whenever users click those suggestions, and by doing so, we can correlate this to the usefulness scores. This validation helps us refine our evaluation methods and ensure real-world performance. Now that we've established the topics of conversation, the conversation and message level usefulness, let's bring everything together. We now know what users discuss and how useful these conversations were. And by combining it, we get a good sense of where our investment opportunities lie. For example, we observe a very high usefulness for mitigation and prevention. But there's very low conversation volume. This might point to a discoverability challenge. Our AI is able to help with these use cases effectively, but our users are just not using these capabilities. So now that we have established observability, how do we guide users to these useful use cases? How can we improve discoverability? This is something that Willian will answer next.
Yeah, Great question. So how do we fix this, right? So from talking with our users, it became pretty clear that without context or prior successful interactions, they don't know where to start, right? So we have the capabilities on our chat and we're developing them on daily basis, but they remain out of reach for our typical consumer. So we tackled this challenge with three key strategies. We call them signpost, contextual suggestions, and follow-ups. And I will briefly describe these three strategies. So what we do with signposts is in our current existing workflows, we add simple buttons that invite the user that hi can help you with a given operation. For example, it can help you suggest a report title or suggest the severity. It's a friendly nudge to our users that, hey, we can help you here. For example, I just click the title suggestion, and it will show you the interaction that Alexander also showed a couple of slides ago. So those are signposts. We place them everywhere. We love them. The next strategy is contextual suggestions, and these are conversation starters tailored to what the user is currently looking at or is working on. It's a very smart system. We even have a version running as an experiment that looks at your screen and tries to figure out what is a logical conversation starter. So in this screenshot here, I'm exploring the submission volume, and it detected that a question could be is like, how does my program report volume compares to industry benchmarks? I think the conversation starters are pretty important because this is typically a question you would not ask without having prior knowledge or context. This also marks a small but significant step for us to drive a more agentic experience where our LLM or our HI is more supports your workflows and works with you instead of just reacting to your inputs. The third strategy we apply is context-aware follow-ups, right? You'll see them in ChatGPT and such as well. Is like, depending on the conversation, we'll show you suggestions on what's relevant. In this case, I'm again checking out my program versus the industry benchmark, and it suggests like, yeah, let's filter on IDARs to IDARs insecure direct object references to see a more specific weakness type. Also very helpful. So in our observations, the combination of these three strategies is very effective. We have signposts and contextual suggestions helping us to start conversations, and we have follow-ups to guide the users that it should be an interaction, and that you can ask follow-up questions to refine the results and yield even better results. What's great now is that we have observability and a way to steer users' behavior. And how we apply it is like every conversation generates new insights and actions, which feeds back to steering user behavior. So we have this continuous cycle where people make more use of HI becomes better. But just don't take our word for it. This is a humble brag. So these are our HI usage statistics. So on the left-hand side, you can see the users on our platform that are currently using HI. And currently, 30% of all of our users interact with HI. And you see the effects of adding various signposts and improvements in our chat. And on the right-hand side, again, a little bit bragging, but this is the retention so people keep using HI, which is best of class, just saying. No. So that was our talk, and we hope that it's useful for you if you implement your chat in your product to see like how do we uncover real value and how can we make more out of HI. Thank you. That was our presentation.
Thank you for the talk. Are there any questions in the room? I see one here.
Roughly, when did you start working on basically the analytics for the chat? Or how long have you been working on it?
think for half a year, but it was a process, right? So this is initially we only used we looked at user numbers, and then we want to cover more insights, and so roughly half a year.
Yeah.
Okay, thank you.
Yeah, rather than tag-based stream generation, did you guys also think about async generation for the messages that are meant for the users and different messages stream for the system analytics?
And that's a good question. So the question was if, in addition to the tag-based extraction that we do as part of the ongoing stream response, if we also do async evaluation. And in a way, our conversation level usefulness is async, right? We do the evaluation outside of the response cycle, outside of the chat interaction. And in the case of chat, we want to have as little latency as possible. Right, so that's why we go with a tag-based extraction approach, so that we can capture it as part of the response cycle without having to execute additional prompts on top of the prompt that actually evaluates the response in chat. So that's why we went with this approach. We did evaluate other options like async processing or executing additional prompts in parallel, but from our experience, it resulted in too much lag or latency in the actual chat interaction and make the chat less intuitive and fluid.
In one of the slides, I think there was an example of a question in the chat like, hey, can you tell me more about, and then like a ticket number, if I remember correctly. Is there anything in place that you do to filter out data that user shouldn't be able to see? So like more of a security concern, I guess.
Yeah, it is a whole pipeline that makes sure that our outputs are anonymized. It is quite an elaborate process, and the data that Alexander was showing here is it's highly processed, right? So we do tag extraction, but the tags are not generic enough. Even though we instruct the prompt like don't reveal any secrets, yeah, it still reveals secrets. So there's like an additional pipeline and an additional check, and it's a little bit technical, I think, but we create embeddings for those topics, and we group embeddings, and then we have like an algorithm that describes like what is this embedding or this cluster about, and that's the data we're showing here. So I think we're safe, but still still LLMs, so we cannot guarantee 100% anonymization, and that's why we still treat this data as confidential data.
One thing to add, so when you look at the report ID itself, right, so in this case, the user is discussing a report that they're actually looking at, right? So this conversation is always within the constraints of the data the user already has access to. Like the context doesn't go beyond the organization or user level constraints.
Yeah, so hopefully that answers your question. Yeah, it's a little bit of a balance you want to have. You want to be as detailed, but within with safe data.
Any more questions? If not, then I would like to thank you both for giving this talk. Give an applause.